Good morning. Today's nuclear chemistry day 1, new chapter. So in front of you, I have a little video you can watch called called Radium Girls on YouTube. It's pretty cool, showing how radium, which is a radioactive element, was exposed to girls in everyday life back then. And yep, over here you have the X-Men and Storm. How do we determine natural transmutation decay? So in the words, guys, look over here. So I see the word says natural, okay? Natural, which means found, naturally, not man-made. I see trans, and then I see mutate. So mutate or transmutate means to change, okay? Something that's naturally changing or decaying, okay? And that's what we're going to learn in this chapter. Nuclear chemistry is all about. So, what can happen when you get exposed to radiation? So hit the pause button now and write down the possible answers. Okay, we're back. Well, one possible really detrimental thing that can happen as exposure to radiation is cancer. Think of skin cancer. Too much exposure to the sun, the UV rays. How about DNA is being messed up, right? DNA mutation, which can also lead to cancer and other disabilities and other problems. All right, let's move on. All right, this is a radioactive symbol. That's the symbol international symbol for radiation. Okay, let's move on over here. Bye, Storm. All right, guys, there's 2 tables we need to learn in this chapter, all right? The first one is table N. Table N over here. Okay. It says the nuclide, these are your radioactive elements here, guys, all right? AU, C14, Ca37. Half-life. Those of you should remember this. We did this in earth science, all right, which is half the amount of time it takes the amount of time it takes for half of the mass to disintegrate for a radioactive element. The decay mode, is either going to be B negative, B positive, well, more of you guys should be positive, and alpha. And where do we find these symbols? Well, if you look over here, guys, on table O, look what it says here. B negative means beta particle, and this is what's given off, either 0, -1e, or 0, -1b. B positive is the positron. It's the anti-electron, basically, okay? Because, guys, see it says beta particle. Beta particle is actually, I'm sorry, let's go back to beta particle. That is actually an electron, okay? And this is the opposite of electrons. This is electron negative charge. Positron is positively charged. And the last symbol that's on table N that we can find on table O is the alpha particle. A is alpha particle. Alpha particle is this guy, helium. You notice it's got a large mass, right? The mass is 4 and the atomic number is 2. Okay. So these are tables we're going to be using, all right? Let's move on. Yes, these are some superheroes. What they have in common? As you know, they all have some sort of genetic mutation, okay? Let's move on. Usually from radiation is what causes these genetic mutations. So let's first go over the first type of mutation you need to know, transmutation you need to know. And here's our table onto the right corner. Yes, this is Wolverine on your left. Yes. Is natural transmutation. Particles are naturally changing, okay? Particles are naturally changing. So, let's go to the first one here, please. Now, natural transmutation of radioactive isotope change into a more stable one, right? So, guys, because radioactive elements do not like to be radioactive long. They like to change eventually into a stable isotope. In other words, something doesn't release energy. So, first I see radium. Radium on your periodic table is Ra. Atomic mass 226, atomic number is 88. So that's the left side, right? So how many particles do we have on the left of the arrow? Well, there's only one over here. Right, just radium. Producing. Now, let's go back to over here. I see Rn, which is radon, is a gas that's found naturally in the earth. Okay, certain parts of it. Not where we are, guys. It's like Delaware, Southern New Jersey, Maryland. Plus 4, 2 He. So helium is 4. Well, if you notice over here, what's 222 plus 4? That's right, 226. And look at the mass on the left, 226. So guys, very simple. Your left side mass must equal the right side mass. All right, look at the atomic number on the left. This is 88. Well, what's 86 plus 2? That's right, 88. So if you notice, even the atomic numbers. So the atomic number on the left is 88. Well, on the right side, 86 plus 2 is 88. Now, how many particles are on the right side? Well, let's see, 1, 2. So 1 on the left, 2 on the right is natural transmutation. Now, I see it says the word here, alpha decay. Well, going back to our table on top, alpha particle is when we are releasing either 42He or 42A. Well, do you see 42He on the right side here? Yes, I do. Right there, 42He. That's what makes this alpha decay. Okay. Next, potassium 42. So the mass is 42. Well, look at the right side's mass. What's 42 plus 0? That's right, 42. Look at the atomic number on the left, 19. What's 20 minus 1? That's right, 19. How many particles on the left of the arrow here, guys? We have 1 on the left, and we have 1, 2 on the right. Again, that tells me it's natural transmutation. Now, look at the particles being released here. Well, we are releasing, it says here, 0, negative 1. Well, according to here, 0, negative 1 is a beta particle. So that releases what's called a beta decay. Okay. Last but not least, let's look at this one here. Iron, 53, Fe. The mass on the left is 53. Well, look at the right of the arrow. Well, what's 53 plus 0? That's right, 53. The atomic number on the left is 26. What's 25 plus 1? 26, very good. Okay. Again, if you notice over here, 0 plus 1 is this guy down here. That is a positron. Aha, so that must make it positron decay. Okay? And again, how many particles on the left of the arrow, guys? We have 1 on the left and 2 on the right. When you have 1 on the left, 2 on the right, that is natural transmutation. Okay, let's move forward. So this is a cool little thing you should look at on YouTube about alpha beta gammas. And cool BrainPOP video. Again, guys, remember, BrainPOP, if you forgot the username and password, I'll give it to you right now, okay? So, username is Sewan Haka1 _ FPM, and the password is school. Okay, let's move on. Now, over here, I have this nuclear decay balancing sheet, okay? So guys, we're going to use the tables, table O and table M. I put them on the side for you so it's easier, all right? So, what's missing over here? Well, if you notice, what they give us? They gave us, the first one is carbon. Carbon says the mass is 14. Well, what's missing? Well, the top number's there, the bottom number's not there. The bottom number for carbon, you have to go to your periodic table. Periodic table says carbon's atomic number is 6. Okay, so now, you look that up, you add that in, very good. All right? Now, let's go over here a second, all right? Carbon 14, we got your table in, guys. Here is carbon 14 right there. Carbon 14, the decay mode says over here is B negative. So B negative is right there. B negative, what is the notation, people? Right there it is. You can either use 0, -1E or 0, -1B. So let's use whatever, doesn't matter. E is 0, -1E. 0, -1E. You do either E or B, does not matter. Okay. So what did we say earlier? We said that the mass on the left must equal the mass on the right. Well, what's the mass on the right given to us? Well, that's 0. 0 plus what gives me 14 on the right? You got it, 14. The atomic number on the left is 6. So we need the right side equals 6. Well, they gave us -1, right? So what minus 1 gives me 6? 7. Very good. Now we got to go to our periodic table. Atomic number 7 is which element? Nitrogen. Okay. Let's move on. FR or francium-220. Again, they gave some mass. We're missing the atomic number. The atomic number you have to go where? What table, guys? Periodic table. Very good. So you go to the periodic table. Francium says 87. Okay. Now, we gotta go find francium now on this table over here. Francium is right there. What is the decay mode they give to us here now? That's right, alpha. Here is alpha. And alpha says over here 42He or 42A. Again, you can use either one, does not matter. Let's just use 42He. So it's a helium particle, okay? Or at least it's helium. Plus. Again, what did we say before, guys? Mass on the left must equal mass on the right. The mass on the left is 220. Well, 4 plus what's 220? 216. Atomic number on the left is 87. 2 plus what's 87? 85. So if you go to your periodic table, the atomic number 85 is which element symbol? That's right, astatine, AT. Okay? All right, we have 2 more problems to do here. All right? Neon, the mass given to us is 19. Again, we must go to the periodic table to look up the atomic number. Atomic number of neon is 10, which means there's 10 protons, right? So, neon, let's find neon on our trusty table. Table N. Where are you, neon? There you are. Neon 19 says over here, which particle now? Which decay mode? B positive. B positive, guys, right, is right there. All right, it's a positron. All right, it's a positron, so it's B positive. So, what is the particle here? It says 0 plus 1E or plus 1B. Doesn't matter. 0 plus 1E. It's a positron. Plus, well, mass left is 19. 0 plus what's 19? Well, 19. The atomic number on the left is 10. 1 plus what gives me 10? 9. Very good. You go to the periodic table. Atomic number 9 is fluorine. All right. Last but not least over here is cesium, the emperor of alkali metals. All right. Cesium's atomic number, again, you must go to your periodic table. All right. So in the periodic table, cesium's atomic number is 55. So you look up cesium on the chart, guys. Let's go to the chart like we always been doing. Cesium, where are you? There you are. It says B negative. Okay. B negative again was this guy here. That's 0, -1E or B. It doesn't matter. Plus, again, the mass left is 137. All right. Now let's take a second over here. So if you see over here, the atomic number on the left is 55. So we say, what minus 1 is 55? Well, it's going to be 56. Then you go to the periodic table, 56 is barium. Group 2 alkali metal. All right, let's proceed. So let's keep going on over here. All right. This is a cool little, this is what they're building. They're going to build out east, guys. Okay, it's called a accelerator. Accelerates particles, and the particles slam to one another, producing new types of elements and particles. This is what's going to be called artificial transmutation. Guys, artificial simply means that it's man-made. We're doing it, okay? When a normally stable atom is bombarded the high-speed, high-energy particle and forced to give off radiation. So in other words, we're doing it, all right? Now, what's the difference over here? Well, how many particles you notice on the left here, guys? 1, 2. There's 2 on the left. How many on the right for artificial? That's right, 2 on the right. All right, because we're doing it. So let's do the numbers over here. This is very easy, all right? What's 27 plus 1? 28. What's 24 plus 4? 28. So if you notice, the mass is still going to be the same. You add them up. What's 13 plus 0? 13. What's 11 plus 2? 13. Okay? Let's figure out the blank over here now, all right? Well, 6 plus 1 gives me 7. 4 plus what gives me 7? 3. 3 plus 0 is 3. 2 plus what is 3? 2 plus 1. Atomic number 1 is hydrogen. Again, guys, you got to go to the periodic table, look up the element. The atomic number tells us the element. All right, let's move on. All right. Again, there's 2 particles on the left and 2 particles on the right, artificial. What's 238 plus 14? Well, that's 252. 251 plus what gives me 252? Well, that's 1. 92 plus 7 is 99. 99 plus what's 99? 0. You don't know. Atomic number 0, you go to table O, that is a neutron. Right? Because atomic numbers on the periodic table goes from 1 to 118. Not to that, okay? Next one. Let's finish it off. All right. Now let's use this color. 23 plus 2 is 25. 1 plus what's 25? That's right, 24. 11 plus 1 is 12. 1 plus what gives me 12? Well, 1 plus 11 gives me 12. So the answer be NA. Again, what do we have in common here, guys, for artificial? There's 2 on the left. There's 2 particles on the right. Well, natural is 1 on the left, 2 on the right. That's it for today. Complete the worksheet. I start.